Welcome to this video number 9 on simultaneous fault. Okay, so this is our learning outcome for simultaneous fault. In this video, we shall deal with H type of fault, that is series parallel connection. Now, this type of fault we get by 4 different possible combinations. So, here LG fault at ith bus and one conductor fault at jth bus. So LG fault, as we know that it is series, uh, it will give you series parallel series connection of sequence network, and one conductor open gives parallel interconnection of sequence network. So it can fall into this category H type, that is series parallel connection. Similarly, there is another possibility, LG fault at ith bus and LLG fault at jth bus. So that also will give you series parallel combination. Similarly, two conductor fault at ith bus and one conductor fault at jth bus. This also will give the combination of series parallel. So H type of fault. Or else two conductor fault at ith bus and LLG fault at jth bus. So that combination also come into this H type of fault. Now let us have some equations. So this figure here gives the sequence network connection for simultaneous H type of fault. Now here we are considering, say, like LG fault at the input port and uh, one conductor open type of fault at the output port. So this positive sequence network, as already told, it is in now terms of all these two port networks, positive sequence two port network, negative sequence network, zero sequence two port network. They are in terms of H parameters. Okay, so now this positive sequence network, it represents a two port model of the positive sequence network, and this is the two port network of negative sequence network, and this is the two port model of zero sequence network in H parameters. So these are the equations here you can have to get the positive sequence voltage and current at ith and jth bus. Okay, so Vi, it is a positive sequence voltage at the ith bus, and Ij is the current at the jth bus, positive sequence. And this vector will give you the pre-fault voltage and pre-fault current at the ith and jth bus respectively. And this is the H parameters of the positive sequence network. And II and Vj represent the positive sequence current at the I, and Vj1 represents the positive sequence voltage at the jth bus. Now we are having a transformation so as to take care of on which line the fault is taken place. So we have taken one isolation transformer, and this is the these are the ratios of that isolation transformer. Substituting these ratios into this equation, we get this equation over here. Okay, so this is Vx1. It represents the voltage at the x x location where the fault is taken place, and this represents the positive sequence current of the fault current at the I location, I location where the fault is taken place. And this is as similarly pre-fault voltage at the ith bus, and this is pre-fault current at the jth bus, and this the H parameters get modified in this way, and here we have this positive sequence voltage at the ith. Um, uh, this is, I think you will have here Ix and here Ix1 and Vy1. Okay. Next, similarly, we can have equation for negative sequence voltage and current at the uh, ith and jth bus at x and y location actually. So Vx2 Iy2, and now we will not have that default voltage and current parameter here, and this equation gives you the voltage, negative sequence voltage at the faulted voltage and current at the faulted location. Similarly, this equation C will give you the negative sequence voltage, zero sequence voltage and current at the x and y location. And now we have to apply the constraint. The constraint is Vx Iy is equal to sum of the Vx1, Vx2, Vx0. This now we have to substitute here from equation A, here from equation B, and here equation C. Then, and arranging the terms, we get this equation, final equation. So this is the model which you can use to find the voltage and the current at the faulted location. Now here this H parameter, this is the equivalent H parameter, and how we can find it out. Uh, this we can actually find it from the Z parameters. So why we are using Z parameters? Because we know how to find Z bus. Actually, we can. It is easy to find Z or form the Z bus instead of forming the H bus. But we have a building algorithm for Z bus. So what we do in actual practical case, we find Z bus as if it is a two-port network. We are considering only two ports seen from the faults, and then we find the corresponding H model by this equation. Okay, so up to this only in this video. Thank you very much. We will see some problem which are asked in the university exams in the next video. Thank you very much.